You know that feeling, right? You're at a stoplight, an electric car pulls up next to you. The light turns green, and there's just this faint whir, and it's just gone. It's that silent, instant acceleration that just plants you in your seat. It feels like something out of science fiction. So let's break it down and really get into the science behind that incredible speed. So, yeah, that's the big question we're tackling. Why do these cars, from your everyday family sedan to the wild hypercars, feel like they're being launched off an aircraft carrier? Well, it's not magic, it's pure physics. And honestly, it's pretty fascinating. All right, the biggest, most important reason for all this performance boils down to one single powerful word: torque. This is the absolute bedrock of an EV's speed advantage, so let's make sure we're all on the same page about what it actually is. To put it simply, torque is just twisting force. In a car, it's the force that gets the wheels spinning and gets you moving. It's that initial visceral oomph you feel that shoves you back in your seat when you really accelerate. And the way an EV delivers that oomph, well, it's a completely different game than a gas car. Okay, think of it like this. An electric motor, it's like a light switch. You flip it, and bam, you get 100% of the power right now. A gasoline engine, though, it's more like an old gas stove. You turn the knob, and it has to build up. It has to get hot before it really gets going. It needs to rev up, sometimes to thousands and thousands of RPM, just to find its power sweet spot. And that's the absolute key. The very instant your foot even thinks about touching the accelerator in an EV, that motor is giving you every last bit of its available twisting force. There's no buildup. There's no waiting. It's just go. But believe it or not, that's only part one of the story. So you've got all this instant force. But how does the car deliver it so incredibly smoothly? Well, that brings us to the second huge advantage: totally uninterrupted power. And it's all about something an EV doesn't have. Just think about a normal car for a second. The engine makes the power, but then it has to go through this whole mechanical dance, a clutch, a gearbox with a bunch of different gears before it can ever get to the wheels. And every single time the car shifts gears, there's a little pause, a tiny little hiccup in the power delivery. Now, contrast that with this. An EV's drivetrain is just beautifully simple. You've got the motor, a single gear, and the wheels. That's the whole shebang. The power just flows in one smooth, continuous, unbroken wave. No pauses, no delays, no interruptions at all. So, at the end of the day, all those little milliseconds that a gas car loses during every single gear change, they really add up. For an EV, they just don't exist. It's just a constant, relentless pull from a dead stop all the way up to its top speed. Okay, so we've got instant torque and uninterrupted power. Those are the two heavy hitters. But there are a few more kind of secret weapons in an EV's arsenal. Let's call them the hidden helpers that are working behind the scenes to make that acceleration even crazier. First up is just raw efficiency. An electric motor is incredibly good at its job, converting something like 90% of the energy from the battery straight into motion. A gasoline engine, you're lucky if you get 30%. The other 70% is just wasted as heat. So in an EV, way more of that precious energy is being used for one thing: pure, raw acceleration. And then you have the brains behind the brawn, the computer. The power electronics in an EV are like a supercomputer on wheels. They can manage the power with millisecond precision, sending the exact right amount of torque to the wheels to get maximum grip without just uselessly spinning the tires. It's a level of control that is literally faster and more precise than any human could ever hope to be. All that tech is amazing, but there's one more advantage that's based on pure, simple physics, and it's hiding in plain sight. Right there, underneath the floor of the car.
Yep, we're talking about the center of gravity. That battery pack is the heaviest single part of an EV, and the designers put it as low and essential as they possibly can. This gives the car an incredibly low center of gravity, which has a massive, massive impact on how it launches.
So how does that help? Well, when any car accelerates hard, the weight naturally shifts to the back, right? The nose lifts up. A low center of gravity fights against that effect. It keeps the car way flattered and keeps all four tires pressed firmly into the pavement. And more contact with the road means better traction, better grip, and that means the car can actually use more of that instant torque without just turning it into tire smoke. So you take that instant torque, you add in a perfectly seamless power delivery, you mix in hyper-efficient motors, control the whole thing with a lightning-fast computer, and then you plant it all to the ground with a super low center of gravity. What do you get when all of that comes together? You get performance that completely changes our idea of what speed is. You get a number that, just a handful of years ago, would have sounded completely impossible for a car you can actually buy. 1.99 seconds. Under 2 seconds. I mean, that's faster than you can fall. It's the kind of acceleration that multi-million-dollar hypercars have struggled for years to achieve, and now you can get it in a four-door family sedan. This right here is the result of all that science working in perfect harmony. Let's just put this into perspective for a second. Check out this showdown. The EV is a full second faster to 100 kilometers per hour than a legendary gasoline supercar. A full second. And you can see exactly why right down the list. Instant torque versus having to wait for 7,000 RPM. Continuous power versus power that's interrupted by shifts. And millisecond computer control. The physical advantages are just undeniable. It's really a fundamental shift in what performance even means. And it just leaves you with this one final, really exciting thought. If electric cars are already doing this today, completely redefining what we thought was possible, what in the world is the car of tomorrow going to feel like?